Hi, today we're going to talk about reflections, and the I can statement we're working on is I can reflect points on a coordinate plane. So just let's review the coordinate plane. The horizontal axis is called our x-axis, and our vertical axis is called our y-axis. And that's important because when we are reflecting, we're going to be reflecting over one of these two axes. So it's important to know which is the x and which is the y. Now, a reflection is a flip. So if I were to take this arrow and reflect it over the x-axis, what that means is I'm going to flip it over the x-axis. Notice I did not change shape or size of my original figure. I've just simply flipped it over. I've created a mirror image. You might also notice that what I'm looking at on my graph is I have now a symmetric figure where the x-axis is my line of symmetry, meaning that every point on this arrow here is going to be the same distance from the x-axis as every point on the bottom arrow here, my reflected point. Let's look at a reflection over the y-axis. I'm going to take this arrow and I'm going to flip it or reflect it over the y-axis. Again, you might notice I did not change the shape or size at all. All I did was flip it upside down on itself over the y-axis. Once again, every corresponding point from my original to my new reflected shape should be the same distance from the y-axis. So if this point, we're going to call it A, is 4 units from the y-axis, its reflected point, which we're going to call A prime, meaning when I put that little apostrophe, that means that it is the reflected point, that will also be 4 units from the y-axis. The same should be true for every other point on each of these shapes, that from their partner, from their original to the prime vertice, they should be the same distance from the y-axis. Let's explore this a little further. Go ahead, pause the video and plot these points. Okay, let's see how you did. When you plot these points, we've actually created a right scaling triangle. Not so important that you know the name of it, but that's going to become important in just a second here when we talk about these shapes, these points. Go ahead and plot these points, and as you do that, make some observations about your original figure and the new one. Okay, let's see how you did. When I plot these points here, you might notice that you have created another right scaling triangle. Other things you might have noticed is that their bases are the same. Their heights are the same. So what we've done is we've created a reflection of the blue shape. In this case, I have reflected this triangle over the y-axis. Now let's look at what that means. If this is point A, B, and C, this would be A prime, C prime, and B prime. Look at their distance from my line of reflection. In this case, it's the y-axis. A is 1, 2, 3 points from the y-axis, so is C. A prime is 1, 2, 3 points from the y-axis, so is C. B is 1, 2, 3, 4, 5, 6, 7 units from the y-axis. B prime is 1, 2, 3, 4, 5, 6, 7 units from the y-axis as well. Now let's take a closer look at their ordered pairs. We know we've reflected the shape over the y-axis. What do you notice about their ordered pairs? You might have noticed that the x values are opposites of each other, where the y values stayed the same. When I reflect over the y-axis, all I really need to do is take the opposite of the x value of my original shape to get my reflected shape. Now, because I did not move this figure up or down at all to reflect it, none of my y values are going to change. Let's look at another problem. Go ahead and connect these points on a coordinate plane in your composition books. Okay, let's see how you did. What we've created here is a triangle called a right isosceles triangle. Now, let's plot these points, and as you do, think about what you notice. Okay, let's see what you did. When you plot those 3 points, you might have noticed that you've created another right isosceles triangle. And in each case, the base is 4 and the height is also 4. So you have created 2 identical shapes, except the red one is flipped upside down from the blue. What we've done here is we have created a reflection over the x-axis. So if the x-axis is my line of reflection, each point A, B, and C, and its corresponding points A prime, B prime, and C prime, are going to have the same distance from the x-axis. So I'm going to start at A and count 1, 2, 3, 4, 5 units to get to the x-axis. If I count down 5 more, 1, 2, 3, 4, 5 units, I'll get to A prime. B is 1 unit from the x-axis. B prime is 1 unit from the x-axis. C is 1 unit from the x-axis. C prime is also 1 unit from the x-axis. So what I've created here is a reflection over the x-axis. Let's look at their ordered pairs now. What do you notice about their ordered pairs? You might have noticed that the y values this time are opposites, whereas the x values didn't change. When I reflected this shape, I didn't shift the new shape left or right. So they stayed in line with their original shapes on the x-axis, but what changed was their y values. And when I reflect over the x-axis, my x coordinates are going to stay the same. My y coordinates are going to be flipped. So these triangles are actually a reflection of each other over the x-axis. Okay, go ahead and plot these points. Okay, let's see how you did. Now we're going to draw a reflection of this shape over the x-axis. So go ahead and do that. What are your new ordered pairs? After you've created the reflection over the x-axis, meaning I'm jumping over this axis, my new ordered pairs are going to be -8, 2, -3, 2, -3, 4, -8, 4. Notice my x values did not change when I flipped over the x-axis, but my y values did. They became the opposites of the original. Let's try plotting this figure. Okay, we have a triangle. Now reflect that over the y-axis and list its ordered pairs. Okay, let's see how you did. When I flip it over the y-axis, that's a horizontal flip. I'm going to get a mirror image of my original, and my ordered pairs are going to be 7, -4, 2, -4, and 2, -2. Notice this time when I flipped over the y-axis, my y coordinates stayed the same, but my x coordinates became the opposite of the original. We're done with this video now. It's time to go ahead and practice these skills on quadrant 2. You can go back and watch this video as many times as you need, or you can watch the whole thing, but don't forget the WSQ in your notes.